Welcome to this video, which is going to examine piecewise functions and show you how you can express a absolute value function as what is called a piecewise function. So to do that, I'm going to first give you a quick demonstration of what piecewise functions are and how they work and how they are used. So if you look here, you will see what I would call piecewise functions. So first of all, let's just kind of look at their appearance. So they'll have f of x equals or y equals. You'll then see this set builder bracket, but it'll be a large size one. There is no set builder on the right side. It's just a one-sided bracket. And then a piecewise function will have layers to it. So it'll be a function that will behave this way if you put an x value in that's smaller than 2 in this example. And then it will behave this way if you put an x value in that's bigger than or equal to 2. So it's a function that acts differently depending on the x value that you put in, but it's all considered to be the same function. So for example, if I want to evaluate f at -2, I need to determine which piece of the function I should use to make this evaluation. Now remember, this is your x value. Oops. So if x is -2, that is a number that is less than 2. That means I'm going to use this piece of the function. So it's going to be negative, replace x with -2, add 2. So that's going to give me +4. F at 5. Again, x is 5, is a number that's bigger than or equal to 2. So I'd use this piece of the function, 5 minus 2. So that would give me a value of 3. 0 is a number less than 2, so I'd use this piece of the function. So negative, put 0 in for the x, add 2, I would get 2. Now the only one that may cause some confusion, we say, what if it's exactly 2? Well, then you got to go for your equal sign. So my equal sign is on this one, so if x is equal to 2, I would use this one, which would be 2 minus 2, and it is 0. So depending on the x value that you're working with, that will determine which piece of the function that you would use. All right, so let's look at how is this going to be used with absolute value. So one of the things we want to learn with absolute value is how to manage the two possibilities that could always exist. So for example, if I said the absolute value of x is 6, well, x could be 6 because the absolute value of 6 is 6. But the absolute value of -6 is also 6. So there's always these multiple possibilities when you're dealing with absolute value because of what I just showed you here. So what I have to do is I need to learn how to manage those two possibilities if I wanted to write out the different possibilities without including those absolute values. So for example, in this function, if I have the absolute value of x plus 3, I want to look at the two scenarios. What if between the bars was some positive number, and what if between the bars was some negative number? Now before I get to that, let's just look. I got a couple of little notes I made here. If I have a numeric example, I said the absolute value of the number 4, we would all agree that the absolute value of the number 4 is 4. The absolute value of -4 is 4. This scenario I'm going to refer to as the acronym BBP. Between the bars is positive. These are your bars. Between them is a positive value. Here's my bars. In between them is a negative number, so I call that BBN. Between the bars is a negative number. Well, having said that, if I took the scenario here, absolute value of 4 equals 4, and I said, I'm going to write this statement, but I don't want to use absolute value bars. If I just took my eraser and erased the absolute value bars, wouldn't this situation be a true statement? So if between the bars is a positive number, you really don't need them, and you'll still get a true statement. Now, if you take this scenario, so I got -4, absolute value, which we know the answer is 4. But if I wanted to write this without using the bars, so I go -4 equals 4, I say, well, I just erase the bars. Well, unfortunately, if between the bars is a negative, you can't just erase the bars because it doesn't make a true statement. Well, what would be we know that between the bars is supposed to come out to be a positive. Well, if between the bars is a negative, what other math process could we use that would change it to the positive that it's supposed to be? Well, the answer to that is to take the negative number and multiply it by a -1. So if you multiply between the bars by a -1, it will switch it to positive, the way it's supposed to be, and then it will be a true statement. So this scenario, when between the bars is negative, I have to write it out without the bars, but then I have to multiply between the bars by a -1 to switch it to the positive value that it's supposed to be. I don't have to worry about that if it's already positive. All right, let me backtrack here for a second. So I had this one, and let's examine the two possible cases of this one. So the first scenario is maybe I'll put some x value in here that will make between the bars positive. Well, the first thing I have to do is figure out what kind of x values would make that happen. So take x plus 3 between the bars and make it bigger than or equal to 0. That's what positive numbers are. They're greater than. Now, I'm going to put 0 into this situation, or into this case, I guess I'll call it. 0 is neither positive nor negative. I just tell students to make sure you put it in one of the two possibilities. So I'm going to put it in the positive possibility. Well, the only way I'll get a positive value is if I put something in there that's greater than or equal to -3. So, for example, any number bigger than or equal to -3. 0 plus 3, yep, I do get a positive. Well, if this is the scenario, so if the x value is greater than or equal to -3, I don't really need the absolute value bars. My function's just going to behave as if those bars weren't even there. But if between the bars is negative, and maybe we'll put it beside it here. So between the bars is negative, well, let's say what would make that happen? So if between the bars, there's x plus 3, that's between the bars. What if it was less than 0? That means it's negative. That would only happen if the x value I inputted was less than -3. Then you would get a negative number in here. Well, if that's the case, your function, you can't just write it without bars. You have to take the negative of what was between those bars. So when you take the negative of this, it would just become -x, take away 3 instead. So what we then do at the end is we make what's called a piecewise function. So I go y equals, use my set builder bracket, like so. And the function will behave like x plus 3, just the regular old x plus 3 function, if you put an x value in that's bigger than or equal to -3. But if you put a number in that's less than -3, the function will behave like this instead. So I've taken this absolute value linear function and I've written it as a piecewise function. So you're going to have to examine the two possibilities. What if between the bars is positive? What if between the bars is negative? And that'll give you your two layers to your piecewise function. Okay, let's take a look at this one. So the format is pretty standard. You have to say, well, what will make between the bars positive? Between the bars is x minus 5. So x minus 5 would be positive if it is greater than or equal to 0, and that would only happen if x was bigger than or equal to 5. So if that's the case, your function will just behave like normal, except you don't really need the bars because they're not going to do anything. So I'll just, maybe I'll expand that out. 2x, take away 10, plus 4, so y would be 2x minus 6. Now if between the bars was positive, was negative, I just did positive, well, I got to figure what would make that happen. So between the bars, x, take away 5, if that was less than 0, well, that would be if x was less than 5. So if x is less than 5, that means there's going to be a negative number in here. So if there's a negative number in there, I have to take the negative of everything in the bars to switch it to a positive, the same way the absolute value bars would. Now this would become negative 2x plus 10 plus 4, y equals negative 2x plus 14. Now you could have, instead of writing it this way, Another way to get a negative to go through those bars would have just been to switch this 2 out front to a -2. Right, that would have the same effect. If I expand that out, I get the same thing as this. All right, now the last thing you got to make sure you do is put this all together in your piecewise function. So y equals set builder bracket. Y will equal 2x minus 6 if we pick x values that are bigger than or equal to 5, and y will be this, -2x take away, plus 14 if we pick x values that are smaller than 5. Took an absolute value function and I've written it as a piecewise function. All right, here's one more linear, and then we're going to move on to quadratic versions of these. All right, so let's look at the two scenarios. What if between the bars is positive? So between the bars in this question is the expression 3x plus 8. We need to figure out what would make that positive, greater than or equal to 0. So 3x would have to be greater than or equal to -8. Divide by 3, divide by 3. So in order for this to happen, I'd have to input a number that's bigger than or equal to -8/3. So if you do that, your function will just be -4, regular brackets, take the place of your absolute value. Clean this up, -12x minus 32 minus 5. So my function would behave like so if between there was positive. If between those two bars was negative, so that would happen if 3x plus 8 was less than 0. 3x is less than -8, x is less than -8/3. Well then, my function, so this time, to get a negative to go through there, I'm just going to stick the negative out in front with this. So a negative of this would switch it to a +4, 3x plus 8. That would have the same effect of me putting a negative in here, which you could if you felt more comfortable doing that. And that would give me now 12x plus 32 minus 5, y equals 12x plus 27. Put that together, y equals -12x subtract 37 if we put an x value in that's bigger than or equal to -8/3, 12x plus 27 if we put an x value in that's less than -8/3. Changed an absolute value linear function into a piecewise function that does not include absolute value symbols any longer. That's kind of the goal, to write it as a function that doesn't use absolute value, that will cover the two possibilities of your absolute value, the positive version and the negative version. All right, well, we extend this. We need to be able to do it also for quadratic versions of these. Now, the good news is the process does not change. It's the exact same process. So I would say, all right, I need between the bars to be positive. Well, between the bars, x squared plus 3x minus 10 is greater than or equal to 0. The difference now is this is no longer linear, where you just move the number over and you divide. This is a quadratic inequality. Section 4.1. Go watch the video if you forget how to do these, but you're supposed to know how to do these now. To do these, you find the zeros. X plus 5, x minus 2 equals 0, which would give me two zeros, -5 and 2. Then you draw a sketch. -5 and 2. And notice what I don't do. I don't find the vertex. It doesn't matter where it is. You're just going to be wasting time finding it for a question like this. All I need to know is that it opens up. So if it opens up, it goes through like so. And what I'm looking for is where this quadratic would have positive y values. Well, it's going to have positive y values here and here. What I want you to find out or tell me are what are the x values that gave us these highlighted regions of the graph. Well, to get those regions of the graph, I would have had to pick x values out here or x values out here. Because if you pick an x value here and I say, where does that hit the graph? Up here where it's positive. That's where it's greater than or equal to 0. So this graph will have positive values between here if you pick an x value that's less than or equal to -5, or you pick an x value that's bigger than or equal to 2. And if you do that, the function will just behave like this without the bars. It's the positive version of it. The negative, now the good news is when you go to do the negative version, this is all the same legwork. All you're looking for this time is where is the quadratic below the axis. Well, I want to switch colors. That is here. So you got to figure out now what x values give me that loop on the bottom. Well, that's these ones in here. So to get the loop down here where the y values are less than 0, I would have to pick x values that are found between -5 and 2. So if that's the case, that means there's a negative between here. If you pick an x that's anywhere between here and here, you're going to get negative y values. Well, these bars are going to switch that to a positive. I'm not going to use bars, but I still need to switch it to a positive. So the way I'm going to do it is just like I did in the linear one. I'm going to run a negative through this absolute value bracket, and that'll turn it into a positive value. So here's my piecewise function. Y equals, I set brackets. It'll just be this regular function. Throw the brackets or the bars out if it's the positive version. So that will be if x is smaller than or equal to -5 or x is bigger than or equal to 2. If you pick an x value in here, this will be a negative quantity, but I need to switch it to positive. So to do that, I need to multiply through by a -1, which will make it -x² subtract 3x plus 13 if you have an x value that's in this interval. So I've just expressed a quadratic absolute value function as a piecewise function using the exact same process. Difference being, I had to recall how to solve a quadratic inequality, which is what this is. And now if you may say, where did you get this from? I solved this quadratic inequality, x² plus 3x minus 10, which is this sketch I've drawn. Where is that less than 0? It's less than 0 in this interval, right down there. Okay, here's another one. Again, I'm going to go back here and reiterate. I did not find the vertex of this. Never fails. Students end up trying to find the vertex here, which it doesn't hurt anything, but it's a waste of your time. Because it's unnecessary when you go to solve this. And that'll be the same students will say, oh, I ran out of time in that test. Well, they ran out of time because you didn't listen to the instructions in the process that say you don't need to find the vertex, and you were going ahead and find the vertex anyway. So when you're doing this, don't find the vertex. Now, this gets confusing because students say, well, you said earlier I have to. I said you need the vertex if the instruction said sketch this, then you need the vertex. I'm not asking you to sketch this, I'm asking you to write it as a piecewise function. Okay, down to this one. So I've got to look at the two scenarios, say what would make between the bars positive. So between the bars is -x² plus 25, and I want that to be greater than or equal to 0. So I need to find the zeros of that. -x² plus 25 equals 0. I'm just going to switch the order, or let's multiply it by -1. So x² minus 25 equals 0. Now it's different to squares. X take away 5, x plus 5 equals 0. So I get two zeros, plus or minus 5. It opens down this time. So -5 and 5. I'm going to draw it opening down, like so. So when the between bar is positive, so this time the quadratic that we see here is positive up there. Well, that's going to be generated by picking numbers in here. So the between bar is positive will come out of the interval -5 is less than or equal to x is less than or equal to 5. That's how you're going to get positive values on your quadratic. Now, the quadratic -x² plus 25 to be negative, so between bars negative, less than 0 means negative. So it's the same quadratic. Well, you're going to get negatives if you pick x values here or here, their y values are down below the axis. So this will be if x is less than -5, or you pick x values that are bigger than 5. Now you put that together in a piecewise function. So let's do that right here. So f of x would equal. So if between the bars is positive, you pick numbers in here, then you'll get just this regular function without the bars. So that would be if -5 less than or equal to x less than or equal to 5. Between the bars is negative, which means it needs to get switched to positive by multiplying through by a -1. That would happen if you were to put a number in that was less than -5 or a number that was bigger than 5. And there's the piecewise version of that absolute value function. Let me see. We got one more. Let's do this one more then. Or do I got two here? Let's do the more difficult one. Let's do this one down here. Okay, so to solve this one, I need to say what would make between the bars positive. So between the bars, greater than or equal to 0. So find the zeros. Multiply this by a -1. So 3 times -8 is -24. So I want to get a -2. So that's 3x minus 6, 3x plus 4 equals 0. Divide by 3, divide by 3. X minus 2, 3x plus 4 equals 0. So my zeros are 2 and -4/3. Draw my sketch. So -4/3 would be there, 2 would be there. This opens down again. So I open it down. So between the bars is positive on this top loop here, which are numbers that are between -4/3 and 2. This quadratic is negative, so between the bars is negative. So this quadratic is negative if you pick numbers that are less than -4/3, or you were to pick numbers that were bigger than 2. Right out here, they'd also give you negative y values. So then you just put that together on your piecewise function, f of x equals, so it stays as is if x is in this interval, because it would be already positive. So -3x squared plus 2x plus 8 if the x value you use is somewhere between -4/3 and 2. And it's the negative version, which means you'd have to multiply by -1 if you pick a number that's less than -4/3 or you pick a number that is bigger than 2. And there you have it. That is how you take, in this example, we've taken a quadratic absolute value function and we've written it as a piecewise function. Alright, so that was my goal of this video, is to show you how to do both linear and absolute value functions and how to turn them into an equivalent piecewise function. Alright, so thanks for watching. Again, use the video as you need to rewind, rewatch, do practice examples, whatever it may be. And now when you're done this video, you should be able to do the formative 4.2